Hey there, pre-algebra students. Welcome to our pre-algebra review for our mid-chapter 4 test. Now, this is specifically for my awesome pre-algebra A students. All right, if you're in pre-algebra B, there is a separate video for you, so go ahead back to our YouTube page and check that out. Now, let me just get this focused for you. All right, so today we're going to go over all of the topics that will be featured on your upcoming quiz. Now, this chapter is all about fractions, so this video and your quiz will cover prime factorization, simplifying fractions using prime factorization, identifying equivalent fractions, and multiplying and dividing fractions. Now, with all of that, we are going to remember to always be simplifying. So this is going to be a really important topic that we're going to go over. Now, before we get to it, though, I do want to remind you guys that notes will be allowed on this quiz. So if you want to take notes on this video and put those in your binder to bring with you on next week on Wednesday, then absolutely go for it. You can use your notes. Just make sure you come prepared, all right? So remember to bring your notes, and that's going to be Wednesday. All right? So with that being said, let's move on to the math. First, we're going to go over prime factorization. So this we learned around Christmas time, and we call them our Christmas trees. When we want to find the prime factorization of a number, we're taking a composite number, meaning a number made up of other factors or a product of other factors, and we're going to break it down until we break it down into its smallest possible factors. So 72 is where we're going to start. Now, with 72, there's a couple different places we could start when breaking it up. Some of you may already know of a multiplication fact that comes to mind when you think of 72. However, let's say on a test or a quiz, we blank out. It happens sometimes. What are we going to do? Well, let's look at our number. It ends in a 2. One of my divisibility rules reminded me that if it ends in a 2, the number is a even number, and that means it can be divided by 2. So if I do 72 divided by 2, I get 36. So I'm going to start there. 36 times 2. Now 2 is a prime number, so I'm going to circle that. But 36 is composite, meaning it's not prime. It has factor pairs, more than just 36 times 1. So we're going to continue breaking this down. So 36, I know 36, the first factor pair that comes to mind is 6 times 6. If you come up with a different factor pair, use it. It's not wrong. It will all get you to the same answer if it multiplies to equal the number you're trying to break down. So 6 times 6 would work. 3 times 12 would work. There are lots of options here. So 6 times 6 is what I chose. I'm going to break 6 down into 3 times 2 because 6 is composite. But 3 and 2 are prime, so those will get circled. And then when we're doing prime factorization, we don't leave it like this. We write it in expanded form as well as with exponents. So first we're going to do expanded form, and the trick for expanded form is to count carefully. Especially when we have a lot of factors, it can get a little messy. So I want to count carefully. I have 1, 2, 3 2's. So that's 2 times 2 times 2. And I have 1, 2, 3's. So that's 3 times 3. Now I'm going to write it with an exponent. So I'm going to count once again 1, 2, 3. 3 2's, so that's 2 to the third power, and I have 2 3's, so that's 3 to the second power. So that would be my final answer. I need to make sure I have both parts included. Okay, let's try another one. 128. Now 128, again, maybe I don't know where to start, so let's divide it by 2. Let's start at the basics. So 2 times 64 equals 128. Now 2 is prime, so I can circle that, but 64 is not, so I'm going to continue breaking that down. I think I recall 64 can be broken down into 8 times 8. So let's do that. 8 times 8. They're not prime though, so we're going to continue and break that down into 4 times 2 for each of those factors. 2's are prime, so that can be circled, but 4's are composite, so we'll continue and break that down to 2 times 2 and 2 times 2. We look and make sure there's no other numbers that are composite left hiding, and we got them all. So let's count out our factors for our expanded form. Now this one, notice it's all 2's. So I'm going to count carefully, make sure there's no 3's or anything else hiding in there. There isn't. So I've got 1, 2, 3, 4, 5, 6, 7 2's. So that's 1, 2, 3, 4, 5, 7. Notice how carefully I'm counting. It might sound silly, but it's super important because that's where mistakes happen here. Just from rushing, you know. So we got 7 2's, 2 times 2 times 2 times 2, and so on. Now I have to also write it with an exponent, so that's 2 to the 7th power. All right, so there's our examples of prime factorization. Let's move on to simplifying using prime factorization. So we can simplify in a number of ways. You may have learned how to simplify in elementary school. When we simplify, we are basically dividing our numerator and denominator to try and find common factors and then cancel out those common factors. So when we're using smaller numbers, you might be able to do it in your head. But now that we're in pre-algebra, we're using larger numbers and we're introducing variables. So we're going to use prime factorization to simplify. The first thing we do is take each of our pieces of our fraction, our numerator and our denominator, and we're going to find the prime factorization of each one. So I'm going to start with 22, which is 2 times 11. So that's already simplified there. And that's both prime. Then I'm going to break down 34 into 2 times 17. So those are my prime factors. Now I'm going to write my 2 prime factorizations back in my fraction form. So 22 was 2 times 11, and 34 was 2 times 17. Now we have to simplify, so we're going to look for factors that appear on the top and the bottom, basically twins, that can cancel out, because remember, fractions are division, and 2 divided by 2 is 1. So we can cancel those out, basically pulling them out of our original numbers, leaving us with our simplified factors. So the 2's cancel out, 11 and 17 don't cancel out, but there's nothing left besides that. So our final answer is 11 over 17, and that is our simplified version of 22 over 34. Let's move on and add some variables to the mix. Here we have 35b to the 3rd power over 50b. So the first thing I'm going to do is what I did in my first problem. I'm going to just pull out my coefficients, 35 and 50, and I'm going to find the prime factorization of those two numbers. So 35 breaks down, we can do 5 times 7, and those are both prime. 50 breaks down into 5 times 10. 5 is prime. 10 can be broken into 5 times 2. So now we're going to take our prime factorizations and we're going to write them in our fraction form with our variables. Don't forget the variables, all right? So it's 5 times 7 times b cubed. So that's 3 b's. b times b times b. Then 50b is 5 times 5 times 2 times b. Now I would normally put my smaller number first, like I'd put it in numerical order. However, I noticed that my first factor, my smallest factor in my numerator was 5, and it's easier for me to cancel them out if I can match them up. So I started there, especially because I didn't have any 2s, so I knew I wouldn't be canceling this out. Now, 5 over 5 cancels out, and b over b cancels out. So now we're going to circle what's left. 7b and another b, and 5 times 2, but no variables left. So that's 7 times b over 5 times 2. And that gives us 7b squared over 10. There's our simplified answer. All right, because remember, b times b is b squared. The 7 is our coefficient. 7 times b squared is 7b squared, and 5 times 2 is 10. Let's do another one like that. So we have 28x squared y over 14xy cubed. So again, I'm going to first find the prime factorization. So 28, I can break that into 2 times 14. 14 breaks into 7 times 2. 14 breaks into 7 times 2. Oh, there we go. All right, so now I'm going to rewrite my fraction with my prime factorization and my my variables. So the top 28 broke down to 2 times 2 times 7 times x squared, so that's x times y. All right, now 14 broke down to 2 times 7 and then x, so that's just 1x, times y cubed. So that's y times y times y. Now we'll cancel out what we can cancel out. So that's 2 2's there, 2 7's there, 2 x's, and 2 y's. So we circle what's left just so we don't miss anything. And then let's rewrite it. 2 times x is 2x, and y times y is y squared. That's all that's left. So there's our simplified fraction. 2x over y squared. Let's do one more, and this one has a negative. So the first thing I'm going to do is look and see, are there any other negatives that might cancel it out? And there aren't. So I'm just going to remember that my final answer needs to be negative, and then I'm going to kind of put that negative off to the side and not let it distract me. I'll bring that back at the end. So instead, I'm going to just start with my numbers like I've done for everything else. So 21 and 35. 21 is 3 times 7. 35 is 5 times 7. So I'm going to rewrite this as negative. 21 was 3 times 7 times y. And 35 was 5 times 7. And then it's y, z. Now remember, we talked about this in class. I want to remind you, when you're writing your z's, I highly recommend doing your best to make them look very different than your 2's, because it's very easy, look right here, for them to look similar. So I always add this extra line that looks kind of like a belt, just to make sure I know that's a z and not a 2. So now that I've rewritten that, I can cancel out what I see that appears twice. I've got 2 7's there, 2 y's there. So what's left over is negative 3 and then 5 times z, so 5z. And that's my final answer. All right, so now let's talk about equivalent fractions. We've learned that we can use a trick with equivalent fractions called the butterfly method or cross multiplication. Butterfly method is my personal name for it. You won't find that in a textbook. Cross multiplication better describes it. We are going to be multiplying across and then comparing our cross products to tell if our fractions are equivalent. If they're equivalent, that means they represent the same amount, just using different digits for their numerator and denominator, meaning the whole is split into a different number of parts, but the same fraction of parts is represented. So let's do the first one. 2 times 11, that's 22. And 5 times 4 is 20. Those are not equal numbers, so this is not equivalent. Let's do the next one. Here we have 4 times 15, that's 60. And 10 times 6, that is also 60. So those two fractions are equivalent. All right. So that's our test. Our cross multiplication tests if our fractions are equivalent. Next up, we're going to perform some operations. And in this case, they are multiplication and division. Now, when we're multiplying and dividing fractions, we do not need to have common denominators, but we do need to make sure we are always simplifying. So we've learned a trick to make sure we always simplify. We are going to simplify first for all of our problems, primarily when multiplying, but we've learned division really is multiplication when it comes to fractions. So we'll see that in a minute. Let's start with our first one, 4 over 7 squared. So that's 4 over 7 times 4 over 7. Now, the first thing we would do is see if we can simplify first. And to do that, we look at our diagonals to see if they have any common factors. 4 and 7 do not have any common factors because 7 is prime. So we can't simplify, so instead we multiply straight across. So 4 times 4 is 16. And 7 times 7 is 49. Now, because we couldn't simplify in the beginning, we already know we're not going to be able to simplify at the end. So our final answer is 16 over 49. Let's look at the next one. 2 over 3 times 5 over 6. Here we're going to look at our diagonals to see if we can simplify. 2 and 6 do have a common factor. They can both be divided by 2. So 2 divided by 2 is 1. 6 divided by 2 is 3. Now, if I look at my other diagonal, 5 and 3, those cannot be simplified. So my new multiplication problem is 1 over 3 times 5 over 3. From here, I can simplify straight across. It's 5 over 9. And I know because I simplified first, I don't have to simplify at the end. I am done. My answer is 5 over 9. Now let's look at another one. Here's where it really comes in handy to simplify first because we have some larger numbers. And let's say I multiplied 28 times 35 or 28 times 25 first. Simplifying that might get a little tricky. So instead, we're going to remember to simplify first. But before we even do that, we want to notice we've got a negative times a positive. So we want to remember that our answer is going to be negative, just so we don't forget that at the end. From here, we're going to look and see if we can simplify anything. My first diagonal, 5 and 25, they have a common factor. The common factor is 5. So 5 divided by 5 is 1. 25 divided by 5 is 5. Then I'm going to look at my other diagonal. We've got 28 and 35. So I'm going to ask myself, all right, what can they be divided by? That's common. They can both be divided by 7. 28 divided by 7 is 4. And 35 divided by 7 is 5. So I have 1 over 4 negative, don't forget, times 5 over 5. Now from here, I could multiply straight across, but remember that trick we learned where we simplify by crossing out the numbers or letters that appear on the top and the bottom? Well, here we go. We've got negative 1 times 5 over 4 times 5. The 5's cancel out because 5 divided by 5 is 1. So this is really negative 1 over 4 times 1. Well, we all know that that is negative 1 over 4. So that is our final answer. Next, let's add some variables to the mix. Here we have variables and division. So we have 3x over 7 divided by 5 over 6x. For division, we learned to use a trick called keep, change, flip. So that means we're going to keep our first fraction the same. So that'll be 3x over 7. We change division to multiplication. And we flip our second fraction into its reciprocal. So that will be 6x over 5. Now from here we see if we can simplify anything. In this particular case, I look at my diagonals and I don't have anything that can be simplified. So I'm going to end up multiplying straight across. 3x times 6x and 7 times 5. Well, 3 times 6 is 18, and x times x is x squared, and 7 times 5 is 35. So my final answer is 18x squared over 35. All right. It would have been nice if we could have simplified a diagonal, but sometimes we can't. Now let's look at our next problem, another division problem. This time we have negative 6 over 5 divided by 2 over 3. So we're going to use our KCF, our keep, change, flip method again. So we're going to keep negative 6 over 5. I notice it's a negative divided by a positive, so I have to remember that my answer should be negative. I'm going to change divide to multiply, and I'm going to flip 2 over 3 to 3 over 2. Now I see if I can simplify, because my next step would be to multiply, and I know before I multiply, we simplify. And 2 and 6 do have a common factor. 6 divided by 2 is 3. 2 divided by 2 is 1. So my new problem is 3/5, negative 3/5, times 3 over 1. So from there, I'm going to multiply straight across, and I get negative 9 over 5. Now, we would also want to make sure to write this in a mixed number, since this is improper. So that's going to be negative 1 and 4/5. All right. Moving on, our next one is another division problem. This time we have 16 over 27y divided by 8 over 15y. We're going to keep, change, flip. So 16 over 27y, we keep that. We change divide to multiply, and we flip 8 over 15y to 15y over 8. Now before we multiply, we see, can we simplify? And we can. First, we have 16 and 8. They have a common factor of 8. 16 divided by 8 is 2. 8 divided by 8 is 1. Then we look at our other diagonal. Do we have any common factors? And we do, all right? 15y is 3 times 5 times y, and 27y is 3 times 9 times y. So we can simplify that. They can both be divided by 3y. So 27y divided by 3y is, by 3y is 9. And 15y divided by 3y is 5. So our new problem is 2 over 9 times 5 over 1. We've simplified out our variables, so there's no letters left. So when we multiply, we get 10 over 9. And then we turn it into a mixed number, and we get 1 and 1, 9. Okie dokie. Let's keep rolling. Up next, we are going to evaluate some expressions using the strategies we just reviewed. So remember, when we're evaluating expressions, they're going to give you an expression, and then they're going to tell you a value for each of the variables in the expression and ask you to evaluate, meaning solve with those values. So in this case, we have xy, which we remember is x times y. And our variables are x equals 2/5. So I'm going to replace x with 2/5. And y equals 5/6. So from here, we're going to multiply like the directions asked us to. So we remember when we multiply, first we check for diagonals that can be simplified. So 2 and 6 can be simplified. They can both be divided by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. Our other diagonal, 5 and 5, those also have a common factor. They're the same number. That means they can both be divided by 5. So 5 divided by 5 is 1. 5 divided by 5 is 1. So our new problem is 1 over 1 times 1 over 3. Don't you love it when it simplifies so nicely? So this, when we multiply, we get 1/3. All right, so we evaluated xy and it equals 1/3. Now let's evaluate a division problem. They're asking us to evaluate x divided by y this time. X is 7/6 and y is -1/2. All right, I see a negative. I got to remember that. Answer needs to be negative because there's no other negative to cancel it out. So I have 7/6 divided by -1/2. I'm going to change flip. So 7/6 times -2/1. 7 and 1 cannot be simplified. They're both prime. But 6 and 2 can both be divided by 2. So that simplifies to 1 and 3. So my new problem is 7/3 times -1/1. So our answer is -7/3 or -2 1/3. All right. My dogs are very excited about that. Don't know if you can hear them in the background. All right. Lastly, you guys have worked hard, not only in class this week and with your homework, but by watching this video in your free time. This was extra practice that was not required, and you guys have taken the time to watch this whole thing, and I'm very proud. So, as a reward, you will be getting an advantage towards our bonus question on the quiz. On the quiz, I will be asking you, what is the only number that is spelt with letters arranged in alphabetical order? Okay, so what is the only number spelt with letters arranged in alphabetical order? Well, that would be 40. F-O-R-T-Y. If you say your alphabet, you're going to come across each of these letters in this order. But surprisingly, out of the infinite number of numbers in the universe, this is the only one that is spelt in alpha order. So that's pretty cool. Fun math fact. And now when you see this trivia question on the quiz for a bonus point, you have a heads up, you know the answer. All right, guys, so please study. Make sure your notes are in order for this open note quiz on Wednesday. And have a great rest of your weekend. I will be available in the Math Center or by email if you need help. Otherwise, I will see you in class Wednesday. Bye, guys.